Okay, it's running. So, Tim Time projects here. Well, Tim Time. Anyhow, I was using my fluke meter a couple of weeks ago, and you might have caught it in one of my videos if you're an avid watcher, that the 500 slug quit working. So sometimes it did work, sometimes it didn't. So I pried this cap off, the little white cap. I pried this off, and I actually just used my thumbs and pried it off. But when I pried it off, it's off now, so I didn't redo it. This part right here, and I'll see if I can kind of show you. That was loose, laying in here, and it fell off and hit the ground. And it looks like just a little tang, and it sits up there like that, and it's soldered on this end, I believe. That's the way it looks like it should go to me. But since I never actually saw it together, and since you can't find pictures of these anywhere, very proprietary, that was the assumption I made, so I soldered it on. I did video the whole thing, but I seem to have either lost it or erased it, or maybe I didn't turn the camera on. So I pick up where I actually solder it on and give it a shot, and that's where we're at. So we'll pick up there. Okay, so I soldered that on, and it still didn't work. And I don't know how it really went on. I was just assuming that was it. So the next logical step was to take it further apart. Now I found out I soaked this in. I set it down in here, and I soaked it in some alcohol for a while. And then I just kept working around here with a real small screwdriver, and it did mar up the edge a little bit here. But you don't have to drill anything on. It's just glued here. That little dot is an indexing spot that goes into here. That's just so you put it together the right way, or so it's not crooked. But yeah, that's glue. That's glue. Not sure if it works again, what I'll do to glue it back together, but so much for that. And in here, I guess there's a little hole there, and that you can fit a little screwdriver in to check it out, or to adjust. There's a resistor in here. So I'm going to take it the rest of the way apart and see what happens. I saw a couple online that, let me see if I can get this better into, yeah, I saw a couple online that had all different ways that this connected. So like I said, I think I showed you when I took this off, this was laying there. It had fallen. I'm sure me taking this off. This I just kept working back and forth with my fingers till I was able to pull it out. Just kind of an interference fit in here. So I'm going to put this over here, get it out of my way, and hopefully not spill my alcohol bath somewhere. Next would be to take this screw out, I guess. That's the next logical step. We'll see how that works. See how that works for us. I want to move the camera further away so you can get more of a view of what's happening here. All right. Out comes the screw. Not sure what's going to happen now. Oop, there we go. So I tapped it, and that came apart. There's the indexing pin, and it goes right here. So here inside here, I can see there's the potentiometer. And not sure what the two sides go to. I see a little screw. There's a little screw here. Down in here. And it looks like maybe that helps hold the back on. Not sure. So the first thing I want to check real quick is, I'm going to just set it on here. I'll check and see if the pot has any resistance to it. Maybe it just got dirty contacts. This has a stamp on it. It says November 19, looks like 90 maybe. It just says November and then 90, so assuming that's 1990. 0.2 ohms. All right, let's try it again, see what we get here. Okay, 19k ohms, so that's working. So I think we have to take it further apart. And where this leg is on this side, I believe there's a diode in there. You can see there's a screw right here. I'm hoping I could pull that up out of there. There's the insulation. That can go there. Now I should be able to get to those two screws. There's one. That would be the one that was in the insulation. All right, here's two. Those two screws came out. All right. Once I did that, as you can see, now there's a piece of metal in here. I don't know if this is just dirt. There's some Teflon from the ring. But here's the working components. Maybe I can get a better view. Pull you down like that. See if we can light it up some. I don't know if I'm going to be able to open that up too much more. Maybe I can get some stills. All right, I see two capacitors. And then there's that diode. And a little resistor in there. I don't know if you can see all that. All right, it looks to me like there's a wire hanging that would come from this transformer. There's no way for me to show you that. You can only see it under the microscope. So let me see if I can take more of this apart. I'm going to add here too. It seems this either at the factory they do really shoddy work with the wrong tools, or this has been apart before. That lead is like 99% off. And there's a little bit of solder on one spot. All right, get that one off. So now I just got to work on the other one. Move this guy out of my way. I'm going to try the solder sucker again. Let me move this screw out of my way because that's going to get knocked. All right, so there it is. Now I can look at that wire. Put this back here. Okay, here it is. It's gonna be hard to really see, but you can see you kind of see a lead hanging around right here. Where is it at? I don't want to poke it. This is a toothpick, by the way, to give you an idea of the size that I'm dealing with here. But you can kind of see that it's loose. If I can. I think it was wrapped around twice, but it's loose. Oh, there's one over on this side too that's underneath all that crap. I can't, that one doesn't seem to be loose, but I'm gonna have to get there with the magnifying glass and give a better look just to make sure. This here one I'm gonna need to solder a little bit. So I don't know what the story is with this one, why it's so long and flopping around like that, but see what we can do. All right, well, I went to put it back together, and when I was examining it under the microscope, I found that one of the capacitors is cracked, and I just gently pulled on the lead, and it pulled right out of the body. So, of course, I have every size capacitor you could ever imagine, except for that size. Uh, that's 1,000. It'd be 1,000 picofarad. So I'll grab one. If I can't find any around here. I looked on even old boards, but I'll get it. So stay tuned. Well, I got my capacitor here. One side on. Well, this one came over here, and it wrapped around this resistor. Didn't really miss much but me just soldering, and all you could see with my hand. Okay, so here's the finished product. Come on, focus in. There you go. All right. All right, not really sure where I left off here, but I wanted to check while I was in there the diode, and when I checked it in circuit, it gave me some anomalies. It looked like maybe it was working, but not like it should. So anyhow, I pulled the diode out of the circuit, and as you can see it right here. So when I test it on diode test, and I test negative to the cathode and positive, tells me about 2.16 volts. So that would probably be forward biased. Turn it the other way, so I have negative to the anode and positive to the cathode. And I get about 2.16 2.9 volts, which, let me see it. 2.8, yeah. Oh, low battery. Anyhow, so assuming this is just a regular diode or like a Schottky diode, I figured let's try some 1N34As. And here would be forward biased, about 3.21 volts. And now if I negative or wire it the other way, so that positive's on the cathode, it shows me an open, and that's what I would expect to see, provided that's just a standard diode. So I'm going to try, I realize this is a little bit bigger, actually it's a lot bigger, but I'm going to try throwing a 1N34 in there. I don't see how it could have that much voltage across it. That, anyhow, so we'll give that a shot and we'll see what happens. So let me get back to that. Okay, so there, this is the best I can get. That is the diode. And you can see that little wire that travels up and down from each end. And then it touches on, I don't know if you'd be able to see it, but there's like a little plate that it touches on. Looks like a little square plate. And that's, I'd imagine that's the PN junction where the positive and negative come together. Now it has this coating on it that's white, black, yellow, and that may well tell me something, but I try to look it up and it pretty much tells me, unless you know who the manufacturing is, that who the manufacturers, that's not real helpful. I don't know if I believe that or not, but the size comparison between that and a 1N34, oh, I'll pull one of those out. We'll look at one of those as well. Come on, you can get in there without moving too much stuff. You can see that. That's quite a bit different. And I don't know if that PN junction voltage, I don't know what that is, but that could possibly account for the calibration being so far off that I can't get it to calibrate. I can bring it up to one setting, as you saw, but then the next setting's out. And I guess maybe once you get up to like 100 watts, it might be fine going all the way up. But so let me see if I can do some more research and find anything on this. Here it is with no backlighting on it. Well, very little anyhow. Maybe it makes it easier to see. Okay, I got the 100-watt slug in there. Let me zoom in a little bit. And we'll key the radio. I'm going to take the microphone off so that I don't get anything. All right, that's showing me almost 100 watts. This is saying 90. So 90 watts. And now we'll try the new rebuilt slug. I didn't put the cover on it, but, and this will be to adjust it. And I'll set transmit. So it's a 50 or a 500, so it'll just be add a 0 to what's over here. So where it's 10 should actually say 100. So we'll be a line below that. Let me lock that in. All right, so here we go. All right, so that reads the same as what the 100 does. So let's see if we knock it down to 50. Get this microphone out of my way here. RF power, we'll put about half. All right, that's about 50. According to that. Let's see. Let's see what this says it is. This is saying, this is more in line with what the radio is actually reading. About, let me knock it down to 50 here. Oh, I had the wrong one, I think. RF power. There, the radio says about 60, this Bird says about 50. So let's see what we get with this. So the 500, there's 100, so 50 would be right there. What's the same we get? This is saying 30. Now let me just see if there's 50. So now let's see, when I go to 100, which is full power. I must have turned the wrong one. Power. Here we go. Now this is saying something outrageous. So the scale's not linear. I'll just put it in and see. I'll throw that around. That'll teach you the lesson. All right. Yeah, they're saying 90. All right, so it definitely made a difference, but it's not working the way it should. So let me do a little more research into this. Maybe try a different diode, and I'll be back, hopefully. Well, I know size isn't everything, but here's the diode that came out. Here's the 1N34A that I got from Amazon. Here is a new 1N34A. It's supposed to be made by someone like ITT or something. I don't know. But definitely is size-wise a lot closer. I'm going to try it and see what kind of response we get with the put the signal to it. Okay, so here I have the two diodes connected through the 12K resistor in series. They're in series with the function generator supplying in parallel, and I'm testing Basically, I'm just looking at the voltage drop. It could be either side, and I'm going between the resistor and ground. I have it set at 5 megahertz, and that's 400 volts, 400 millivolts peak to peak. The yellow is the new diode, the new 1N34A, and the purple, I'm not sure what color that's going to show up on screen, but the purple, the larger one, that's the old diode. I don't really know what I'm looking to see here, and I guess probably the best way to do it would be to build the exact circuit that's inside the element. I'm just looking for something different, and here I see something different. At that voltage, it really looks like, it almost looks like it's just acting like it's not really doing anything as far as being a diode goes. But I have no idea what kind of voltage I'm dealing with there. But you can see that it's a drastically different wave. So that's what I was just looking for, something different, because I don't know what to expect or what to look for here. So we'll give that a try. We'll put it in. There's definitely something different, and we'll see how that one works. All right, well, these parts ought to know their own way out of here by now. Let me get a towel and a holder onto thingy. Yeah, it's a Kleenex. There they are. Okay, so we're back to the ICOM, and let's see, what's it saying? I get that's the 500 slug, so that would be just add a 0 to anything on the middle column. And if I transmit this on AM, it's saying about 15 to 20 watts. So it should be somewhere in that area. Let's see, no, it would be somewhere in this area. $500. Oh, that's 200, 100. That'd be 50. So it's pretty close. I'm going to turn it to 100 watts. We'll have to go to FM to do that. We'll go to FM, and I'm going to transmit. That's showing a little over 50 watts. So if this is a 500 scale, 500, so everything, just move it over. So that would be 100 watts, so it should be down to here somewhere. So it's actually reading kind of high. I'm going to actually give it full power. Let me just make sure that I don't have anything come back to the radio. Very little, okay. We're going to go back to full power on FM, and we're going to set it for 100 watts right about there. So that should be, that's saying 100, the meter's saying 100, and we will check it with another one in a minute. Let's set it down to 50 now and see what it says. Transmit. Okay, that's showing me 50. That's saying exactly 50. So far, so good. Here is a 100 watt slug. So in FM, it should pretty much be the full Monty. So let's see. Saying about 93. About 92, 93. So Let's turn it down. I'm going to turn it down until it goes to 50. 100-watt slug, so 50, which right there. Okay, there's 50 exactly on that slug. Let's try our newly rebuilt 500. So since it's a 500, 50 will be that line right there. This is saying about 65. Let's see. The radius ain't 50. Let's see what this shows us. This is 1,000. So that'd be 200. There's 100. So it should be halfway in between those two. Yeah, it's a bit low. That's saying 40. Let me see the 100 again. I want to just confirm that it's 50. Yep. Now, it might look a little bit different for you because the meter's turned to me. So that's the problem with analog meters is depending on your viewpoint or your vantage point. All right. So we're looking at 50, right? So 500, there's 150, should be that line. So now if I give it full power, where does it go? Right about 90 something. What does the 1000 say it is when it's at 100? So 1100 should be that line right there. And that's saying 75. So let's look at the watt meter that doesn't cost $1,000. Antenna. Transceiver. Okay, so we'll look down at this. In its day, this one was probably $30. So let's see. Put on the 200-watt scale and one for power. Average and PEP doesn't really work, but 200-watt scale. So 100 is going to be this right here. So it's going to be the 200-watt scale. So since we don't have one, we have a 2,000-watt scale. So anyhow, 2,000, 1,000, we're on 200, so it's going to be this line right here. Well, see, to me, it looks like I'm right on it, but the camera's way at an angle. So it's going to be this line right here. What do we get? Almost exactly 100. And this thing's, I don't even know how old it is, but and it cost 1/10 of what that cost. Let's put on the 2,000-watt scale. 1,000, so that'll be way down here where it says 100. That's what we'll look at there. Look at that. Can't get any better than that. All right, so we'll say that we have successfully repaired our 500-watt slug to pretty accurate. I mean, depending on which meter you want to go by. I have 4 different meters here. All 4 have given me different numbers. So I'll clean the glue off of this and glue it back on, and we'll have the slug. And I think the lesson to learn here is that not all 1N34 diodes, actually not all electronic parts that you buy from Amazon or eBay or wherever, are created equal. Why is that doing that? Maybe it's mad at me for talking about the bird. Okay, well, there you have it. I hope this helps, and I hope maybe you can use the pictures from the inside. And I'll put this guy back on and glue this back on. I got to decide what kind of glue I want to use with that, but using a little bit of alcohol takes this right off. And I mean like denatured or rubbing alcohol. All right, thanks for watching. See ya. All right, now if I can just work this in here.